Hi everyone. You just finished watching a video on samples and populations about the difference between the two. Now we're going to look at a sample from a population and look at some statements to see if they are supported by the data. So our first example is about Eastside Middle School. Eastside Middle School conducted a survey of randomly selected sixth graders to determine which elective they were most likely to participate in. The results are shown in the table. So we have 3 electives here: Spanish, theater, and art for our sample. Anytime that you're looking at sample or a data set and you're making inferences, you always want to look at the total first. So the first question I'm going to ask is, how many students are in this sample? When you add up 14, 20, and 6, we get 40 total students for this sample. This will help us out in evaluating our statements. We're going to place a check mark by the statements that are supported by the data, and we're going to look at 3 different ones. The first one we're going to look at is students are more likely to participate in Spanish than art. Since we're comparing Spanish and art, let's go ahead and look at those up here. Okay, and it says students are more likely. So do you think that students are more likely to participate in Spanish than art? Looking at the numbers, this is an accurate statement. It's supported by the data, so I'm going to put a check mark because in this sample size we had 14 students choose Spanish and 6 choose art. So this is an accurate statement. And yes, my check marks do look backwards, and that's because I'm left-handed. So shout out to all the lefties out there. Now for our next statement. Our next statement says more students will most likely participate in art and Spanish combined than theater arts. Now for this one, we're comparing all 3. I'm going to go ahead and erase what I have up here. We're comparing all 3, but it says art and Spanish combined and then theater arts. So for art, we had 6. For Spanish, we had 14. And for theater arts, we had 20. So when we combine the 16 and 14, we actually get 20 combined here. Now, if we go back to what the statement says, it says that more students will most likely participate in art and Spanish combined than theater arts. But once we add it up, we see that the numbers are the same. So this statement is not supported by the data. Okay, let's look at our third statement. Less than half of the students will most likely participate in Spanish for their elective. Now this one focuses on Spanish. So let's go ahead and look at Spanish. We have 14, but it says less than half. So we have to know what less than means, and we also need to know what half means. Half means to divide by 2. This is where our total comes back in. We need to figure out what half of the total sample is. If our sample size is 40 and we divide by 2, that equals 20. 20 is half of 40. They're saying that less than half will most likely participate in Spanish. Well, Spanish has 14. So now that we've figured out half is 20, 14 is less or lower than 20. So this statement is supported by the data. Now, whenever you face problems like this, you may have multiple statements that you have to evaluate like we just did to see which one's true and which one's false. So make sure you focus on each statement one at a time. Now, you also may have to make a prediction. So in this example, we have the same data set, but we're going to make a prediction here. It says if there are 200 students in the 6th grade class at Eastside Middle School, how many students should be expected to participate in Spanish for their elective? So again, we're focusing on Spanish here. Now we already know our total is 40. We discussed this earlier. There's more than one way to work out this problem, but we need to start with the information we have from the sample. We know we're going to be looking at how many students chose Spanish that they would most likely take, and we also have to look at our total. So 14 students taking Spanish, and the total is 40. By labeling this beside the numbers, we can make a ratio here. And then we can use a proportion to make the prediction because we know our total number in the sample, but our total number of students in the class is 200. And we're looking for the amount of students choosing Spanish from this larger group. So we can use a variable to represent that. Now, there's more than one way to solve this. I'm going to show you a few different ways. The first way is we can look for a relationship. How do we get from 40 to 200? Now, these numbers look big, but what you can actually do is, since they both have a 0 at the end, if you take off this 0 and take off this one, you can ask yourself, how do we get from 4 to 20? And that doesn't sound so bad, right? Because 4 times 5 is 20, which means 40 times 5 is 200. Now, if we do that with our total, we're also going to do that with the number that shows Spanish. Okay, so we would take 14 and multiply that by 5, which gives us 70. 70 students out of the group of 200 would be expected to choose Spanish. Now, this is not the only way. There's two other ways that I'm going to show you real quick. One other way is that you can simplify our first ratio, which is the Spanish to the total in the sample. We can actually divide both 14 and 40 by 2 to simplify it, and that can simplify to 7 over 20. Okay, that can simplify. Now, this actually makes it even easier to find this relationship once we simplify, because 20 to 200, we multiply by 10. That's a little easier to see for some people. We do the same thing to Spanish, and 7 times 10 gives you 70. So again, you get 70 for your prediction. Now, the other one I'm going to show you, and let's just start back with our original 14 out of 40. Okay. Now, if you're not sure about those, if that doesn't make you feel confident, you can always cross multiply if you need to. Now, these numbers are going to get a little big though. 200 times 14 gives you 2,800, which you can then take and divide by 40. These numbers are larger, but you can still do it. You still get the same answer. 70 students can be expected. So when looking at a population and making inferences about a sample, you may make predictions. You may just evaluate statements to see if they're true or false. But either way, these are some tools that you can use to help you with that.